Before we start, please feel free to interrupt me if you have any questions, and let's have a conversation. I don't want it to be just a presentation. And yeah, so let's just feel free to interrupt. And before I delve into the change itself, let me give you some context regarding like what we are changing. Scheduler is part of the monitoring stack we are working on, which takes care of launching other components of the monitoring stack. You can think of it like a super scheduler. It schedules other schedulers. And because of that, it needs to deal with lots of different types of objects, not limited to Kubernetes objects. So for example, we can have like a CRD from Prometheus, from Cert Manager, and from many other different components. So the current approach is the current approach to this is basically translating all the manifests into static code. So for example, if we go into reconciler and synchronous manifest, get desired state here, it has a bunch of small reconcilers that in turn take care of creating, like making sure that the definitions in Kubernetes, like API, match the ones that stem from the configuration that we submitted. So, for example, this here we're having service monitor objects for Prometheus, and we just create object using Go, using the Go client for Kubernetes. The problem with this approach is that it requires lots of boilerplate. So you need to basically translate all the manifests you have into Go code. Secondly, maintaining this is a problem because you need, every time you bump the manifest, you need to go through the Go code and make sure that everything that was changed in upstream manifest, for example, for new version of Prometheus, is also reflected in the Go code that handles it in scheduler, so that once we bump the image of the Prometheus, for example, the configuration matches the version, the manifest configuration, like the deployments, airbag, or anything, matches the requirements for the new image that we are deploying. Now, so the new approach that in this MR, suggests, and we iterate on here, is using dynamic client from Kubernetes. And the difference between like the client we are currently, like there are 3 different clients in Kubernetes. Like I may mess up the naming, but like the Go client, controller runtime client, and the dynamic client. So the first client just has types for everything. The second one uses schemas to map the types, and it's like somewhere in the middle, I would say, between like dynamic client and the static client. And like the dynamic client itself, it operates on the YAML manifests. And we want to switch to the third type of client that goes, that just drops all this complexity of the Go code and treats all the manifests uniformly. And this is basically
drops
yes?
type safety as well, just saying.
Yes, yes, like, but there's nothing for free. And yeah, and get desired states on synchronized manifests. And this is basically where all the magic function, all the magic happens. And let me explain what are we doing here. The manifests that we download from upstream need to be modified, adjusted to match the configuration of the monitoring stack. And for that, we use customize. So we basically apply the patches on top of manifests that we upload from upstream, and then using the dynamic client, push it to Kubernetes API. And this is done, like the customization itself is done here. So instead of like having like a bunch of definitions that we define, that we have in the Go code, we only define the changes that need to go into Kubernetes manifests depending on the configuration that was provided by the operator. So here, for example, you have customized patches defined using and the parameter here that we are submitting is like, for example, namespace or the host name where the cluster from which the cluster was going to be visible. Here we have like depending on the environment, if it's AWS or simple kind deployment. So we apply different patches, create different patches depending on the configuration. And I will go back to this later. So now moving forward. Once we create the customized patches, we use Krusty library. It's a very simple one because it allows you to basically do what the customized command line does. So just create a file, submit and put manifest next to it and call the Krusty library, and it will return you a bunch of blobs. And for that, so we do not want to write to disk, so we use in-memory file system for that. So we basically create customizations and in memory, serialize them, write them to in-memory file system, and together with the manifest, run the Krusty library and get a bunch of blobs, byte blobs. And now this may seem inefficient, but from what I saw, of course, happy to be educated. That's the interface that Krusty is providing. So Krusty expects a file system with files, and it does the customization on these files. So you cannot just submit like the static types or like blobs directly to Krusty. You need a file system for that. From what I found out. And so once we have this bunch of blobs, decision comes. So we are if we are tearing down the infrastructure, we are using dynamic manifests, the dynamic clients, sorry, to delete all the blobs that we've created, all the objects that we've created. And if we are deploying a new cluster or updating its state, we are we are just submitting the blobs we got from Krusty into Kubernetes API. And this is done here. And to be honest, I'm wondering if this can be done better because it's like a lot of dance between, like lots of conversion between YAML and byte, and again back to YAML. But I was trying to find a good description of Kubernetes API that could explain like what exactly is the interface here, or like some examples, but I haven't found it. So I just was like experimenting and hacking until I got it working. So probably it's not optimal. So yeah. And how it works. So we are going through manifest. So manifest is like a map of byte blobs. And we go through these byte blobs one by one. And we create a new reader. So a note here. So single blob that we get from Krusty can contain multiple YAML documents. And we cannot just submit all these documents to Kubernetes API. We need to just separate them and submit them one by one. So we are starting a new YAML decoder that takes care of this. And we go through each of these resources. and decode them. So this happens here. And we convert them to unstructured. So we convert from a byte blob into an unstructured object. And once we have this unstructured object, we apply it like there's some like this code needs to be changed. So I maybe won't be going into details here also. So the code for comparison needs to be changed. So as I mentioned at the beginning, this is something I need to improve still. But once we determine that the object, that the manifest really needs to be applied, we use server-side apply to upload it into Kubernetes API. Now I can go into more details into in a couple of places, or but let me know if this is clear. Like, does it make sense? Do you have any like feedback? How maybe we can improve? Maybe something can be improved, and whether you just how do you like it? Yeah. So.
I mean, it makes sense to me.
Yeah, same. Yeah, I'm not used to this code base, so I'm just trying to understand. But whatever you said makes sense. I will interrupt you if I need more clarification.
Sure, and I would be happy if I would be happy to also explain how certain components here work, maybe the dynamic client, how we decode manifests, because maybe you will be able, maybe this is something you could use in your MRs or your work. If it doesn't make sense, like if it's something is not clear, then good. Then this is something we could talk about and go into more detail and explain. So this is not about only about MMR, but also about the technologies we use, like the APIs we use, and like how we can use them in other code bases.
So can you show us one more time how you parse a multi-document YAML, please?
Yes. So let's start here. So the manifests object contains a map, and each value in this map is a multi-document YAML. And in the outer loop, we get this. So we get this blob, and then we create a new reader so that we can pass it to YAML or JSON decoder. This is like a Kubernetes utility that I found that can parse Kubernetes. So from what I gather, like the YAML that Kubernetes is using is a bit more. There's some flavor to it. So this is not like a pure YAML. There's some like extensions to it. I think there's one of them is timestamp related, and there is also some extra tooling that Kubernetes provides for YAML decoding. So if I remember correctly, and this is one of these toolings. So and it takes care of like splitting the documents, like it's reading from the blob and spitting out individual YAML documents from this huge blob. And once we get, and it's just like this, just like a normal scanner. It produces these documents until it gets into to the end of the file, where it returns like IOF error. And now here, like it is, there's a helper function that that works with the YAML or JSON decoder. So it calls the decode method, which basically returns another object, just like we would get with scanner. And again, another util that I found in Kubernetes tooling that decodes like this raw YAML document into unstructured object. And yeah, so and the thing that I'm not certain here is that here we are decoding object from YAML from this big big blob using the decoder, and we need to decode it again here using decoding serializer. So it sounds to me as if we were decoding the object twice. So first to get this, to separate it from like the big, from the big document that contains multiple YAML documents, and then we are decoding the object itself. I was wondering if you could do it in the single step, but I haven't found any documentation or example on the internet. So Mikael, does it answer your question? Now, Katik, is there anything like unclear, or Anna, is there anything unclear I could like explain more about like this code base or maybe tooling?
I was a little curious about the part where you mentioned it's dynamic and we lose the types. Could you go over that again? I didn't completely understand what that was for.
Sure. So it's all about this. So this is like a type in Kubernetes API, Go type in Kubernetes API that basically moves that instead of specifying like the types for all the fields. So if so for example, if you're decoding YAML or JSON in Go, you are decoding into struct, and this struct has types and tags and whatnot. And unstructured object is different because it does not care about the types of individual fields. It treats everything as a map string interface. And this interface can be another map or a slice or a field or an integer of anything. So we are basically doing like a very shallow decoding of the Kubernetes object into this unstructured type. And Kubernetes has some like a very and this unstructured type provides some of like a basic methods for you that enable you to work with this object all together. So for example, group object kind, group object resource, and which are used when submitting object to Kubernetes API. But that's about it. You can, if you want to address individual fields, you need to use, just a second, let me set nested slides. Things like, for example, set nested slides. So they are setters and getters for all the kinds of fields that unstructured object has. So you access the data in the object generically, sorry. So you can just get like a map or a slice or a set integer or anything. Does it answer your question?
Yeah.
Anna, do you have anything like maybe I could explain or like clarify?
I think I missed where we got the manifest blob, and why is it multiple blobs of multiple files?
Sure. Let me show you something. So controllers, let me find it first. Manifest. So first of all, dating, delete, deploy, customization, metrics, service mode, reloader, customization. Yeah. So when applying Kubernetes, some of the Kubernetes applications provide you with manifests that define how the service needs to be deployed. And this manifest is a bunch of YAML documents. So for example, like we have here, and they defined apart from the deployment itself, so how the program is actually running on the on Kubernetes cluster, it also defines like what are its permissions, what are its service accounts, what we have also here, deployment, role building. Sorry. Yeah, so all things that are like together make this component work. So we have multiple YAML documents that are working in concert to make like a component behave the way we want. And as I was describing before, like there are multiple, so referring back to what I said before, so there are like single YAML document can have multiple, so single YAML blob can have multiple documents. So this stems from the fact that the YAML or JSON parser tool that I was showing earlier takes this blob that we downloaded for the given application and splits them. So this is like a YAML separator here. And every YAML document between these separators is a separate document. So we are going one by one. So first, this one is parsed and not more. Then this one is parsed, and parsing stops here before the next document separator. So we have multiple documents in a single file. Now, having said that, going back to how we got here. Cluster control, just a second. Deployment is. Now, we use Go embed to store these blobs in the binary. And then, wait a minute, API cluster overrides. Oh, and this is here. Just a second, get resources. Let me show you exactly where it is. Cluster initial manifest, yes. So we embed this YAML that I showed you just a moment ago into Go binary using Go embed. Then we store them in the map in the map of blobs. So every component has its own name, and the value for the entry in this map is like a YAML manifest with all these changes. And once we have it, all these changes for with YAML manifest with all the configuration of the given component, and once we have it, we then use Krusty. And Krusty, so basically what we are doing here, we are creating a temporary in-memory file system using like filesys library in Go. And yeah, so this is like not very efficient, but again, it's something probably that could be improved. We marshal this manifest that we got and write them to a file in this in-memory file system, write a customization, and run a customizer. So maybe maybe I should have also like explained like so do you would you like me to also like describe you briefly what customize is, like customized tool for Kubernetes, or are you more familiar with it?
Yeah, I'm familiar with it.
Okay, so we use customizer library from Krusty, and it basically expects a file system and a path where the customization is, and it does what the command line tool does, but programmatically. So it's like a pretty high-level API, but it's pretty simple. I cannot say that I don't like it. So customizer or Krusty returns a resource map, which is basically some metadata and a bunch of YAMLs, which is, get to know just a moment. Yeah, which can be get here, which we get here. So basically, Okay, I would have to look for the definition. This is an interface, but ASIAM returns a bunch of blobs that are basically parsed in manifest after customize did it thing. And this is where we got the blobs in the first place. Does it answer your question? Is it clearer now?
Yeah, thank you. It makes a lot of sense.
Yeah, so do you have any other questions or how suggestions how we can improve it? Yeah, so happy to go into more details or like discuss aspects.
I have a suggestion of how you can improve it. So I had to do this exact thing basically without customized though some time ago when I was working on the agent initially, and I also stumbled upon this YAML framer, like the thing that chunks the blob into separate YAMLs, and then serializer, and then eventually I asked myself, how does kubectl do it? And then I went and looked, and then yeah, there is a thing called like resource builder or something like that, and you just feed it with blobs and set settings on it, and then call do, and it gives you a bunch of parsed unstructured, exactly what you do here manually.
But this is super. This is cool. Sorry, my German kicks in. This is super cool. I need to check it out.
I can show you the code as well if you want.
Yes. I will stop sharing now.
Yeah. And that's our decoder. That's resource builder, and this thing lives in where? CLI runtime. Builder, you give it the client, and you add streams, your byte readers, and you call do, and then you visit the results, the set of results, and here are your objects.
Cool.
This is what kubectl does. I just copied. Well, no, I have to also do something else here, which I think kubectl doesn't do. But this exists in CLI utils, in another library that we use. It so if you have a custom resource definition in the CRD and you don't have that CRD in the cluster yet, then if you use kubectl today, you cannot apply those two objects together. Kubectl will blow up saying that I don't know this resource kind. So, and there is a bug about it in the bug tracker for Kubernetes. So CLI utils, which is what KPT uses, has this helper function, which I wrote it myself before I found it, basically. Then I deleted my own thing and I used this library. And it looks at the objects that you have. It finds the custom resource definitions somewhere here. Yeah, and then it understands if you have a custom resource over custom resource definition and whether it needs to set the namespace on that object or not. All of that is to just set the namespace for the namespaced objects. But these are the two things: you parse it and then you set the namespace. And that's all you need to do to get that object into a good state.
Understood.
And then I think in our previous conversation I suggested to use CLI utils to apply the objects, and I still recommend you to have a look. And this is what it would look like. This is the applier, that like instance of the library. Basically, you give it a bunch of objects, and you give it information about the inventory, and it applies all that stuff to the cluster. Also deleting the things that should be deleted because your source manifests no longer have them.
I haven't had time to work on this yet, but yeah, I have notes from our previous meeting, and I'm going to apply on all of them. So, do you have any other questions? If not, I may have another topic that you may find interesting. So something like this is like a very short one. So something that you may find useful. So I already discussed it with Mikhail. But if you're not aware, so yeah, it helped me to save some time debugging. Let me find a link. Just a second. So this is like a Golang bug or feature. Like at this point, I'm not sure what exactly. Have a look at this link. So this is like a bit unexpected behavior when parsing when deserializing JSON objects in Go. And if you haven't had a chance to run into it yet, so the gist of it is that Go does not reset the field that like if we are deserializing into an object, it doesn't get zeroed. So you basically, if you have like some previous data in the object, it will get merged with the data you're deserializing, and you will get like an amalgam of the two. And this is pretty unexpected because when basing on like the behavior in the different parts of Go, you would expect that object gets zeroed, or for example, slices get shrunk and then only expanded and and elements added. So I highly recommend having a look at this bug. So maybe you will find it useful if you haven't already, if you haven't had a chance to look at it yet. So, and that's basically all I have to have for today.
Well, the JSON package merges things on top of the existing things. This documented behavior, but I don't know. I didn't know about this specific thing.
This is quite interesting. Thanks for sharing.
The fun part is that they fixed it and they've reverted the fix because it broke things on Google in Google's infrastructure. So it's still open. Yeah, so for the sake of anybody who's watching this video, let me know if you have any other topics or any other questions. If not, then maybe let's stop recording and conclude for now.